Alright, this is Module 2, Lesson 5 for 8th grade. Okay, so it says first consequences of FTS. Diagram below, points P and Q have been dilated from center 0. There's no center 0 drawn on here yet by scale factor R. It says that PQ is parallel. Remember, this line means parallel. And it's kind of cool because, again, that's like the two L's in the word parallel, right? To P prime, Q prime. PQ is 5 centimeters, and then it says later that P prime, Q prime is 10 centimeters. So as we look at these things, we know that these are parallel to each other. If they're parallel to each other, that means that center O has to be somewhere up here and somewhere in this general region, and that would be something we'll do in 1 second. So it says determine scale factor R. Well, based on that, if we go from OG to copy, we can tell this is the original, right? This is the copy because of the primes, right? So we can tell that the OG to the copy is getting bigger. That means that the scale factor has to be a number that's bigger than 1. So if we take the copy divided by the OG, we should get our scale factor to go from OG to copy. So I have 10 divided by 5, these are centimeters. 10 divided by 5 is 2. So my scale factor, says scale factor R, my scale factor is 2. We can prove that by going from 5 to 10. 5 times my scale factor of 2 is 10. B says locate center 0 of dilation. Measure the segments to verify that OP prime is equal to the radius times OP original, and then OQ prime and radius, or excuse me, not radius, R factor, scale factor, O and Q. So again, what we can do is using a ruler, we would just draw a straight line. It's not perfect, I know, but you can just keep drawing it, and then you can do the same thing this way. Draw it this way because it says that they're parallel, and we know from our last lesson that if they're parallel, then that means that we've got this bigger triangle and smaller triangle nested inside each other. That means that realistically that is about where O is, right? Give or take, and use your ruler, right? Extend it out a little. We know that these are parallel to each other, right? So we found that center dilation point, and then it says show your work below to prove that. So what you're going to do is you're going to measure from here to here, and you're going to prove that whatever that number is, when you go to measure this, that's 2 times that. Then you're going to prove it one more time from here to here, whatever that number is. Let's call that y, just so you don't get confused. That this should be 2 times that y amount, or double that amount. Okay. Looking at the next problem here, it says in the diagram below you're given center 0, that's that guy there, right? And array 0 to A, and you'll notice that's drawn as ray meaning because it keeps going, right? The line keeps going, you see that, right? It doesn't stop at A. So it's not line segment, it's array. Point A is dilated by a scale factor of R equals 4. Use what you know about this to find point A prime. Well, if that's my scale factor, I'm going to take that and multiply that by whatever point A is. Point A is over 3 and up 3, right? This is 3 comma 3. Over 1, 2, 3, and then up 1, 2, 3. So I'm going to use that and multiply my scale factor. 3 times 4 is 12, and 3 times 4 is 12, and you'll notice it's on the line too, which kind of helps there, right? 12 comma 12, and we're going to label this A, and then don't forget the prime to say that that is the copy, not the original. And this last problem here, same thing, but you'll notice now that the scale factor is a number smaller than 1. Remember, if it's smaller than 1, we're going to be going down or decreasing. It's getting smaller. so it's going to be going this way on that line, right? 5/12, right? Means every time that I move over 12 times, it's really only 5 times instead. Well, here's the cool thing. Do we see how this is over 12 and up 8? So if it's over 12, 5/12 means go 5 instead. Now we have this line, which also kind of helps tell us that it's going to be on there, and that should be A prime. And then we actually go to label this. This is going to be 5, comma, and then here's where the math comes in. So it's currently, A is currently sitting at 12, comma 8. So if we take each one of these and multiply it by our scale factor of 5/12, well, 12 times 5/12. Do we see how these cancel out and we're just left with a 5 here? Okay, so the same thing is set up here, right? 8 times 5/12. The difference is we don't have anything that cancels automatically, right? But if we look at that, 8 times 5 is 40, and 12 times 1 is 12. 12 goes into 40 3 times, that's 36, right? And then there's 4 left over, right? And you'll notice that there'd be another 0 here, right? And we put a decimal here. And we bring that down. And look, it's the same 40. So it's going to go in 3 again, and 36. And we see the remainder is going to continue to be a 4. So we see that this is going to be a 3 repeating. And if we notice this here, do we notice how it's here? It's not the center. This would be like half. So this is really 3.3 repeating, or we could also call it 3 1/3. So I'm going to use fractions on this, and I'm going to say it's over 5 and up 3 1/3. You could also call it 5, 3.3, as long as you put the hat on top, repeating, and that's where this A prime is. So again, we're taking the scale factor, we're multiplying it by the coordinate point that we know to find the one we don't know.